Welcome back to the Deep Dive. You hand us the source material, and we give you that essential knowledge shortcut, basically making sure you're informed without all the noise.
Exactly. And today we're tackling the latest buzz around image generation AI.
That's right. Google's Nano Banana model. We're strapping in.
We are. And look, instead of just reading the marketing hype, this whole deep dive is based on some pretty rigorous real-world testing.
Yeah, we have these 5 specific, quite challenging tests run by a user. Let's call them Aang.
And Aang was smart about it, systematically pairing tricky instructions with source material, mostly from Wikimedia Commons, to really push Nano Banana's features.
Okay, so our mission today isn't just, like, listing the results. We really want to cut through and figure out the big question here.
Which is?
Is Nano Banana delivering, conceptual magic, giving you these broad, stylish concepts? Or is it about production reliability? Can it actually follow complex details precisely?
Right. Where's that dividing line? We want to find out where it really shines. Seems like style transfer and scene recognition might be its thing.
And where it just, falls apart.
Yeah.
Especially when you ask for complicated compositions or, exact numbers and placement.
Understanding that difference is really the shortcut to knowing how useful this model actually is right now.
Okay, let's unpack it then. We'll go through these 5 tests, starting with the wins, the impressive stuff.
Uh-huh.
And then get into those moments where, honestly, the system's logic just seemed puzzling.
Let's do it.
So first, the good news. This really says something about the model's training, I think. Nano Banana did show some serious capability with artistic transformations and recognizing what's in an image.
Yeah, the first test was straight-up style transfer. Aang used that classic painting, a young woman holding an ermine.
Right, and the prompt was simple. Apply a 90s grunge style.
And the results? Honestly, pretty impressive. This seems to be where it really excels.
It kept the subject's look, her expression, the pose.
And crucially, it included the animal, too. But it completely changed the textures, the lighting, the whole mood to fit grunge. That's the conceptual magic working right there.
But digging into Aang's notes, there was this really interesting point which gets right back to our main question.
Okay.
The AI didn't stick exactly to the source image's composition. It kept the elements, sure, but the final layout. It felt more like typical 90s grunge portraits from its training data.
Exactly. That's key. It prioritized the style over perfectly matching the original layout. It knew what was there, it knew how to make it grunge, but it felt okay moving things around a bit to fit the aesthetic it learned.
Interesting. And we saw a similar strength, didn't we, in prompt 4, the scene modification one.
Ah, yes, the potato room. The source was this black and white photo, very basic space, used for pre-sprouting potatoes, apparently.
Sounds thrilling.
Yeah.
And the request was clear. Add bookshelves on the wall, put a modern green velvet sofa under the window.
And the result was rated rather good, which, is a win for object recognition.
Even with that tricky black and white source.
Yeah, high contrast, B&W, but it still figured out the walls, the floor, the window, which is crucial. And it put the new furniture in relative to those things, turned a potato bunker into, maybe a reading nook.
Okay, but here's where it starts getting really interesting. Because even in these quote-unquote successful tests, technical issues started popping up, kind of blurring that line between concept power and production precision.
Definitely. One thing noted across a couple of tests was altered dimensions.
Oh, right. In prompts 2 and 4, the final image wasn't the exact same size, pixel-wise, as the original.
It might sound small, but imagine you're a designer. You need that image to fit perfectly into a layout or a template. Suddenly having different dimensions means extra work, manual fixes. That's a loss of precision.
Good point. Okay, let's look closer at prompt 2. That was the restoration and colorization attempt.
Right, using Ansel Adams' famous 1942 photo, the Tetons and the Snake River, iconic black and white. The goal, restore it and add color.
And technically
it worked. It was colorized. But the feedback, the subjective part, was really telling.
What did Aang say?
Felt the original black and white was just more dramatic, intense, timeless, nostalgic, especially the clouds and the river. The colorization, while clever, didn't capture the feeling of that B&W artistry.
So it can make color, but it can't really reproduce nostalgia or drama in the same way. That's a human thing.
Precisely. It's a technical success, but maybe an artistic compromise.
But hang on, that raises a really interesting inconsistency, doesn't it?
How so?
Well, if the AI can successfully imagine color for Ansel Adams' landscape, why did it completely miss the explicit instruction for a green velvet sofa back in the potato room test, prompt 4.
Ah, yes. That is the perfect pivot. If you connect those dots, it's a strange contradiction.
In prompt 4, the user specifically asked for a green velvet sofa
Yeah.
in that B&W room. The sofa appeared.
But the model didn't colorize the rest of the black and white room, even though the color keyword green was right there in the request for the sofa.
So the new sofa was there, sort of contextually placed, but the room itself stayed grayscale.
Exactly. So you've got a model that can, on request, colorize a famous 1942 landscape.
Conceptually restoring it, maybe?
Right. But when you ask it to insert a specifically colored object into a different B&W scene, it doesn't apply color globally. It fails on that explicit detail.
That suggests a really deep, maybe hidden inconsistency in how it prioritizes things, like conceptual changes versus very specific granular instructions.
It absolutely does. It hints that maybe it sees colorizing the Ansel Adams photo as a big conceptual restoration job, something it applies everywhere in the image.
Whereas adding a green sofa is just a local edit.
Seems like it. And that doesn't trigger a full color filter for the whole source image. That ambiguity is really frustrating if you need reliable, predictable results.
Okay, so now let's shift focus to the prompts that were genuinely tough, the ones that really show the limits of Nano Banana right now, especially with complexity and needing to follow rules exactly. This is where that production reliability idea just disappears.
Yeah, this is where the model kind of hits a wall. When the instructions need more logic than just recognizing objects or slapping on a style, we're moving from just editing what's there to asking it to create new, complex interactions.
And prompt 3 was probably the hardest test, right? Merging different sources.
Oh, definitely. Aang uploaded separate photos, one of a person, one of a dog,
Yeah.
and asked the AI to create a totally new scene. The person cuddling the dog, specifically on a basketball court.
So multiple elements needing to interact believably in a new setting.
And it failed. Completely. Aang just couldn't get a decent result. That core instruction merging two unrelated things into a specific interaction on a new background, it was just too much.
The output just sort of jammed the sources together, no real interaction.
Pretty much. Disjointed, not interacting. Making new, complex physical interactions from separate sources. That's clearly a huge hurdle for these models right now.
Okay, so that's a composition failure. Now, let's talk about, well, math and space. It raises a big question. How specific can we actually expect AI to be with counting things or putting them in very particular places?
Prompt 5 went right at that.
A counting test. This one was super detailed.
Yes, multiple layers of instruction. The source was a photo of the K-pop group Twice. Crucially, Twice has 9 members.
9 members, got it. And the prompt was really specific.
Meticulous. Create a 17-scale commercialized figurine of the characters, realistic style, place it on a computer desk, and make sure it's on a round, transparent acrylic base.
Wow. Okay, so that's a list. Scale, style, location, 9 specific people, and they all have to be on that specific base.
A lot to keep track of. And here's the big failure.
What happened?
The first images it generated consistently missed 1 person, only showed 8 members.
Wait, even though the source photo clearly shows 9?
Yep, consistently 8.
How does that even happen if it's trained on billions of images? Is it bad at seeing or bad at understanding the request?
It seems like a failure in understanding the prompt, maybe combined with a bias in its training data towards simpler groups or compositions. Because when Aang explicitly told it to recount and try again...
Did it add the 9th person?
It did. The 9th person appeared, but, and this is the critical part, the proof of its weakness here, the 9th person was placed away from the base, kind of floating next to the desk.
No way. So it fixed the counting error.
But it completely ignored the spatial constraint, the rule that all the figurines had to be on the base.
So it prioritized getting the number right over respecting the physical placement rule.
That's the key takeaway from prompt 5, I think. It really struggled with complex adherence, needing to track both the number and the specific spatial detail at the same time.
It seems like it weighted get the subjects right higher than follow the placement rules.
Exactly. Suggests its internal logic is maybe biased towards object recognition over strictly following scene physics or user-defined limits like stay on the base.
Okay, let's try and pull this all together then. What does Aang's testing really tell us about Nano Banana's capabilities right now?
Well, it's clearly pretty good at the high-level stuff.
Yep.
You know, stylistic changes like the grunge prompt.
Yeah, and general scene edits, like recognizing the window in the potato room and adding furniture, that seemed okay.
Right. But where it really struggles is genuine compositional complexity.
Like trying to merge the person and the dog on the basketball court, that didn't work.
No. And it also falters badly when you need really specific counts or detailed placement, like we just saw with the Twice figurine test. Missing people, putting them in the wrong place.
And we can't forget that weird inconsistency with color, right?
Absolutely.
Huh.
Failing to make the sofa green when explicitly asked, even though it could colorize the Ansel Adams photo, that's a big question mark.
So, bottom line, Nano Banana seems like a powerful tool for concepts. Like, if you need a mood board or broad changes, make this look like a painting, it's probably great.
Fantastic for that, yeah. Conceptual magic, like you said earlier.
But if you're counting on it for, say, complex assembly using multiple sources, or tasks needing super specific details, CAD-level precision.
You're going to be frustrated, definitely. Ask it for the concept, don't bank on it for production reliability just yet.
That makes sense. The current version still needs quite a bit of refinement if it's going to be a truly reliable tool for workflows that demand that strict accuracy and precision.
The evidence from Eng's tests is pretty clear. The model still takes, let's say, creative liberties with user instructions, especially when those instructions involve composition, counting, or basic physics.
And knowing that distinction, knowing where it currently fails, that saves you, the user, a huge amount of time and potential headaches.
Exactly. And just as we wrap up this deep dive, here's a final thought, something for you to chew on.
Okay.
We saw the model successfully colorize the famous Ansel Adams photo, right? Doing that kind of conceptual restoration. Yet it failed on the simple, explicit color instruction, the green velvet sofa, in the generic black and white room photo. The sofa should have been green, the room stayed gray.
Right. What's the implication?
Well, what does that inconsistency tell us about how the AI might differentiate between making big, conceptual choices about famous images it recognizes from its training versus just executing literal instructions on more generic or unknown source material?
Is there like a hidden bias? Does it give itself more creative freedom when it recognizes something famous?
Could be. Does it treat iconic images differently? Something for you to mull over until next time.